All right, guys, we're back with section 6 of chapter 4. We're going to talk about regression in median fit lines. Now, be ready to use your TI-83 graphing calculator that came with your computer. And if you forget how to access that, you should have been using it up until this point, but you can go back to the intro lessons at the beginning of the course, and there's one on your graphing calculator, so you could just review that for basic instructions on it. But I'm going to walk you through all the steps of how to do these things on the graphing calculator. So previously in the last section, we used lines of fit and scatter plots to evaluate trends and make predictions. And now we're going to write equations of best fit lines using something called linear regression, and write equations of what are called median fit lines. So best fit line is definitely some vocabulary: linear regression, something called correlation coefficient, and residual and median fit line. All right, so this table shows the total attendance in millions of people at the Minnesota State Fair from 2005 to 2009. And you can use a graphing calculator to find the equation of a best fit line and use it to make predictions about future attendance at the fair. Now, if you just try to go point by point and get the slope, you're not going to get a consistent slope. But when you graph the scatter plot, you'll see that the points kind of form, they have a positive correlation. So best fit lines, you've learned how to find and write equations for lines of fit by hand. And that one you're kind of guessing 2 points to use to get the slope of the line that kind of goes between all the points. But many calculators have complex algorithms that find a more precise line of fit called the best fit line. One algorithm is called linear regression, and that's what I'm going to teach you today. Your calculator may also compute a number called the correlation coefficient. This number will tell you if your correlation is positive or negative, depending on if the number is positive or negative, and how closely the equation is to modeling the data. The closer the correlation coefficient is to 1 or -1, the more closely the equation models the data. So your correlation coefficient is typically between -1 and +1. If it's negative, that means the correlation is a negative correlation. If it's positive, that means the correlation is positive. The closer those numbers are to 1, there'll probably be a decimal between -1 and 1. The closer they are to 1, the more accurately the best fit line models the data. All right, so the table shows the amount of money made by movies in the United States. Use a graphing calculator to write an equation for the best fit line for the data. Now, I'm going to walk you through the steps. The steps are here. The steps are in your book starting on page 255. So you can always refer to these. There are several steps, but if you just follow the steps that we show you here, you should have no problem doing these different steps. So before you begin, make sure your diagnostic setting is on. You can find this under catalog now. Let me clear this off. How do you find catalog? Catalog is the shift of 0. So you hit second, 0, go to your catalog, and then you want to make sure you go to diagnostic on. So you could scroll straight down, or you could hit alpha and then letter D. See the green button? See the green D? If you hit alpha D, it automatically skips alpha D. It automatically skips to the D section of the catalog. So once you get to diagnostic on, put the little cursor there, hit enter, and hit enter again, and it should say done. All right. Now the next step is to enter the data by pressing stat. So the stat key is right below delete, and it'll give you the different options and categories for the statistics feature of your calculator. You want to, under edit, you want just number 1, edit. And what we're going to do is it's giving you, L stands for lists. It's giving you lists. So in list 1, you typically put your X values. Now, if 2000 is represented by 0, then these are years since 2000. So in L1, I'm going to put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And each time you enter a number, you have to hit enter for it to go in. All right. So you should have 0 through 9 in list 1. Then in list 2, you put the incomes, 7.48, 8.13, 9.19, 9.35, 9.27, 8.95, 9.25, 9.65, 9.85, and 10.21. Hit enter. So let's just check those. 85, 65, 25, 895, 927, 935, 913, 748. Good. Okay. So the X values typically go in list 1. The Y values typically go in list 2. You can put in more lists, but we're not going to do that right now. So the second is to perform the regression by pressing stat again. So once you have your list in, hit stat. Then we're going to go to the calculate menu, and there's a bunch of different regs. Reg. You want the linear reg, which stands for linear regression, in AX plus B. That's just like Y equals MX plus B, except they use A and B. Okay, so go down to number 4, hit enter, and it's going to bring it up just like it brought up the diagnostic. Then you hit enter again. Okay, so A stands for the slope. So A is 0.23206, and B is the y-intercept, so that's 8.08872. This R is the correlation coefficient. You see how it's a decimal, it's positive, and it's kind of close to 1. 0.8755 is pretty good. Okay, that means it's the linear regression line, the line of best fit, is going to be a pretty good model and predictor of attendance given the data that we have. Okay. All right, so third step, write the equation of the regression line by rounding A and B values on the screen. The form that we choose for the regression equation was AX plus B, so the equation Y equals 0.23X plus 8.09. The correlation coefficient is about 0.8755, which means that the equation models the data fairly well. So you would have Y equals 0.23X plus 8.08. Or 8.09 if we're going to round. Yeah. Okay. So what I could do is go to my y equals menu, put 0.23x plus 8.09, hit enter. Go zoom, and then hit number 9, zoom stat. And that's our line. Okay. We'll talk about how to graph the scatter plot for the data. So what you could do is get second y equals, that gets you your plot menu. Just choose number 1, turn it on. Make sure the type is on the little dots because we want to make a scatter plot. X list is going to be list 1. Remember, we put the X values in L1, and the Y list is going to be the Y values in list 2. If you ever need to change that, the different lists, L1, L2, L3, L4, L5, L6, are all the second functions of 1 through 6. Okay, so if I wanted to do my X list is like, say, list 1, and my Y list is, say, list 4, I would have to put L4 in. Okay, so I turn that plot on. Now I'm going to make the mark a little square. So if I hit zoom stat again, number 9, it readjusted the window settings so that it would put all the points on the graph. So all the points from the scatter plot, that's what the little squares are. And then the line of best fit. And you can see how the line of best fit goes through the points, and there's pretty much the same amount of points above the line as below the line. And some of them are really close to the line, so it's kind of hard to get them. But you can see that the general trend is that the points are having a positive correlation there. Okay. All right, here's one for you to try. Go ahead and write the equation of the best fit line for the data in each table. Name the correlation coefficient and round the answer to the nearest 10,000th. Let X be the number of years since 2003. All right, go ahead and pause the video and hit play when you're ready. Okay, we're back. So for 1A, you should have got y equals 1.87x plus 28.58, and the R value should have been, which is the correlation coefficient, 0.6142. So that line models it okay. You know, if it's 0.6, that's not that great. But so that means that just means that a line might not be the best way to model that data. 1B, you have y equals 5.95x plus 50.17, and R equals 0.8495. Okay, if you want me to walk through the steps, just reach out to me and I'll walk you through the steps. Now, if we're letting X be the number of years since 2003, your L1 would have been 0, 1, 2, 3, 4, 5, 6, 7. Your L1 in this case would have been 0, 1, 2, 3, 4, 5, 6, 7. So if you let X be the number, if you started your list 1 as 3, 4, 5, 6, 7, 8, 9, 10, then you probably got different values. But if you go back and adjust it and redo it again with L1 starting representing the years since 2003, because that's what it said there, you got to read it carefully. Okay, then you'll probably do a little bit better here. All righty. All right, so we know that not all the points will lie on the best fit line. The difference between an observed value of y and its predicted value of y found on the best fit line. So the observed value is the actual value on the scatter plot. The predicted value is the value of y that's on the line. Okay, the difference between those is called the residual. Residuals measure how much the data deviate from the regression line, how far apart the scatter plot is away from the regression line. When residuals are plotted on a scatter plot, they can help us assess how well the best fit line describes the data. If the best fit line is a good fit, there is no pattern in the residual plot. So let's graph and analyze the residual plot for guided practice 1A. Determine if the best fit line models the data well. Okay, so let's go back here, quit out of that, clear that off. So you obtain the residual plot of the data. So 1A, so I'm going to go stat 1, years since 2003. So it was 0, 1, 2, 3, 4, 5, 6, 6, 7, and then we didn't need the rest of those. And then it was 30, 23, 41, 35, 31, 43, 33, 45. Okay, and then delete the rest of those. You just hit the delete key right here, and it'll delete them out. Okay. So I want to go to y equals and go to stat plot, second stat plot. Now notice 1 is on, so if I hit number 1, I want to turn it off, and then I can go back up to number 2 and turn it on. Hit enter. Make sure the scatter plot is here. Then it says use L1 for XList. It's already in there. And then I want to graph the residual for the Y. So I don't want to put list 2 in there. I'm trying to do a residual plot. So when you're in there, hit second stat, and then number 7 is residual. So second stat, number 7 is residual. Okay, keep the mark as a dot and then hit zoom. And if you hit up, it puts you to the bottom of the list and you want number 9, which is zoom stat. Oops, number 1. Oh, let's go to the list. Okay, I think I know what I did. So if I hit stat, go to calculate, got to do the linear regression first. Okay, make sure you do that because I hadn't done it for this one. So if you're going to do the residual plot, you have to first do the linear regression, which you just hit stat, calculate, and then number 4. Okay. And then stat plot, if I go to number 2, it's on L1 residual, zoom number 9, and it graphs a scatter plot of the residuals. So the residuals appear to be randomly scattered and centered about the line y equals 0. Oop, let me clear that off. Okay, so the best fit line seems to model the data well. So that's what you're looking for. When you graph the residuals, you want the scatter plot of the residuals to be scattered up and down from the x-axis. So the line y equals 0, which is the x-axis. Because what you're really doing is you're graphing how far apart the points on the original scatter plot, how far away they are from the line of best fit. Okay, so you want that to be distances all over the place, so that what that indicates is that your best fit line is kind of right in the middle of the data. Okay. All right, so let's graph and analyze the residual plot for the following data, comparing graduation rates and unemployment rates. So go ahead and pause the video and hit play when you're ready. All right, so when you graph the residual plot like this, you'll have some data here, here, one up here, one up there, one there, and there. Now, while it looks like there's some above and some below, doesn't it look like they kind of go in a curve like that? Right? They're not just randomly scattered all over the place. They kind of go in a pattern that makes a curve, which indicates that a line might not be the best way to model this data. And if you look at the scatter plot of the original if you look at the scatter plot of the data, the original scatter plot, you'll see that the data probably it might have a positive or negative correlation, but it doesn't necessarily go in a linear pattern. Okay. All right, a residual is positive when the observed value is above the line, negative when the observed value is below the line. So let's just do an example here. So if you have your best fit line and you have your scatter plot like this distance right here is called the residual. This is the observed value, and the line would be the predicted value. The distance between those is positive because the observed value is above, or excuse me, the difference is positive because the observed value is above the predicted value. For this one, the residual would be negative because the observed value is below the predicted value of the line. Now, one common measure of goodness of fit is the sum of squared vertical distances from the points to the line. So what they do is they figure out all these distances of the residuals, square them, and then add them together. Okay, you're not going to have to do this by hand. This is just kind of information for you. The best fit line, which is also called the least squares regression line, minimizes the sum of the squares of those distances. So they position the line, and your calculator does all this kind of in the background. It positions the line just right so that all these distances here, 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 here are as small as possible. So basically it puts the line right in the middle of all the points precisely. So we can use points on the best fit line to estimate values that are not in the data. So remember that when we estimate values between known values, this is called linear interpolation. When we estimate numbers outside the range of the data, this is called linear extrapolation. So for what I'm talking about here, so let's say that this scatter plot works from numbers 1 to 10. Okay, and if I use my line, if I use the equation of my line to figure out what it would be at, let's say, 4, that would be linear interpolation because 4 is between 1 and 10. That's somewhere in the original set of data. Okay, but if I go out here to say 15, all right, off the graph, that's not between 1 and 10. That's not between the numbers of the original set of data. Therefore, that's called linear extrapolation. I'm making predictions. And oftentimes, if we're dealing with time, this is like looking into the future, okay? And trying to use the best fit line to predict what's going to happen in the future, okay? So interpolation is when you're using the best fit line to find a value that's somewhere in between the given data. Linear extrapolation is when you're using the line of best fit to predict a value that's outside of the original set of data. Okay? All right, so the table shows the points received by the top 10 paintball teams in a tournament. Estimate how many points the 20th ranked team received. So we want to write an equation for the best fit line of the data, then extrapolate to find the missing value. So we want to enter the data from the table into lists. So turn your calculator back on, clear that. So stat, edit. List 1 is just going to be 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then list 2 is going to be 100, 89, 96, 99, 97, 98, 78, 70, 64, and 80. Okay. Graph the scatter plot. So if we graph the scatter plot, second stat plot, I'm going to turn number 2 off because I don't want it to graph the residuals. Okay. And then I'm going to switch to number 1. Oops. Second stat plot, number 1. I'm going to turn it on. My X list is L1. My XY list is L2. Zoom stat. And there's the scatter plot. Okay. So if I do a regression equation, so stat, calculate, linear regression. Oops, had that one in there. Stat, calculate, number 4, linear regression. And you get the A value is negative 3.12 if you, or 3.32 if I round. And the B value is 105.3 if I round. And you can see that my R value is negative, which means it has a negative correlation. It's 0.76, so the line kind of models the data okay. Okay, so in my Y equals menu, I'm going to put negative 3.32x plus 105.3. Oops, what's going on here? Clear that off. Oh, I know what I did. I hit enter instead of plus. Plus 105. I hit it again, 105.3. Okay, graph it again. What did I do this? Oh, I use the minus symbol instead of negative, and that makes a difference. Okay, so graph it, and you can see our scatter plot here and the line of best fit right here. So the equation is negative 3.32x plus 105.3. Now we graph the best fit line and use the graph to predict the points that the 20th ranked team receives. So this is the first, second, third, fourth, fifth, 10th. If I want to know what the 20th ranked team is predicted to do, go to, you hit second, calculate. Number one is value. I want to calculate a value, and I'm going to put 20 in. Now the reason it gave me this, if I hit number 2, it's saying 20 is wrong. Can't put in 20. Well, the reason is if you go to your window, the X max value only goes to 10.9. So let's make this go to 21. Go back to the graph. Okay. Second, calculate number 1 value of 21. And you get the Y value of 35.58. Oh, I did. So I can calculate 20. You get 38.9. So the 20th ranked team is about 39. So the 20th rank, it's estimated from the graph, and this is linear extrapolation because I went beyond the original set, which went from 1 to 10. I went out to 20 using the best fit line, okay? And that they've received 39 points according to this, okay? All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready. Okay, we're back. So using linear interpolation to estimate the percent of Americans that play online games for the following ages. So remember, what you had to do was you had to enter it into the list, graph the scatter plot, then get the regression equation, the linear regression, that was number 4 on the stat calculate menu, then graph that equation in your y equals menu. Okay, then you go back and you adjust the viewing window so that it goes out as far as you need to. Now this one, see the ages go from 15 to 50. If I'm trying to figure out what happens when they're 35 and 18, that's linear interpolation because those numbers are between the numbers from our data set. So we actually didn't need to adjust the window. Okay, so for 35 years, you should have got approximately 39%. And for 18 years, you should have got approximately 64%. Okie dokie. All right. Well, guys, that's it for this first video. I know that was kind of long, but I had a lot of detailed things that I had to go through with entering the regression equations. So I hope that was very helpful to you. In the next one, we're going to talk real quick about median fit lines, just have one example to do there. So shouldn't take too long there. All right, guys, we'll see you there.